Hey there! I'm really excited to share with you a simple yet powerful way to determine the area of a right-angled triangle using Python. Picture yourself standing in a triangular piece of land. The longest side, opposite the right angle, is like the hypotenuse, and the other two sides are the legs. Now, to find out how much ground that triangle hogs up, we've got a pretty neat formula right inside Python waiting to do some magic. So let's take a seat on this coding journey. Think of the Python language as our trusty steed. It's got all the syntax, libraries, and methods we need to calculate without sweat on our brows. We begin with understanding the basics, and that's pretty straightforward. The area of a right-angled triangle can be found by taking half the product of the lengths of the legs formed by the right angle. Let's write a simple function to calculate this and see how Python helps us along. Here's the code, my friend. Imagine pressing the keys to create this beauty right in front of you. Python definite calculate _area. Area is equal to 0.5 height return area. Pretty easy peasy, isn't it? You just input the length of the base and the height, and bam! Python crunches the numbers and gives you back the area. But hey, as the road to Python wisdom unfolds, we encounter more roads less traveled. Beyond the surface, you might see the need for a script that interacts with a user, asking for measurements, calculating the area, and perhaps even warning them when their triangle has more area than a specific size. For this, we venture into input, output, and loops, plus a sprinkle of conditional logic to keep things interesting for new Python learners. Python definite ask _for _sizes, while true, try, base is equal to float, height is equal to float, return calculate _area except value error, print definite main, area _of triangle is equal to ask _for sizes if area of triangle 100, print else, print if _name is equal to main. Run this script and it welcomes you to enter the base and height, performs the honors, and returns back with a flourish of the calculated area or a friendly advisory note if the area's above 100. Now, if you're thinking, I want something lean and mean, no frills, that's exactly where performance optimization in Python comes into play. By leveraging some of Python's libraries and its ability to handle large arrays of data efficiently, we can tweak this script to run faster and slip into those scenarios where speed is a deal breaker. Python import numpy as np definite fast _area calculation, return 0.5 np.prod base sides is equal to np.array hash replace with actual side lengths, height sides is equal to np.array hash replace with actual heights, areas is equal to fast _area calculation. Feeling like a seasoned coder? There's the next level, real-world applications. Imagine this code part of a larger project, maybe designing a simulation or analyzing aerial triangulation data for surveying purposes. There's your Python to explore. But don't stop there, because the Pythonic path is filled with more knowledge to seek. As we wind down, remember that Python is more than just slices of pie. It's an entire feast of opportunities in the world of coding. Keep feeding your curiosity, keep experimenting, and let the Python community be your guide and support group. Before we part ways, here is a link where more Python wonders await. Visit neeraj.qzz.io and subscribe to TechLab for more insights into the language you just began to love. Keep coding, my friend, and until next time, happy triangulating.